Okay, this is the M1 paper from January 2024. Question number 3, and this is a kinematics question. We've got a constant acceleration for our system, so I'm going to be using the SUVAT equations. It tells me, part a van passes a point A with the speed u. 20 seconds later it passes B with a speed of 28. It tells me that the distance covered there is 400 meters and asks me to show that u is equal to 12. So I'll draw a quick diagram. It's not absolutely essential in this particular question, but I'm used to doing it. From A to B, then what do we have? U is what I'm looking for. I know that this is 400 meters and that it takes 20 seconds to do that, and I know that at the end there it's traveling with a speed of 28 meters per second. So I'll put my SUVAT down. We know that S is equal to 400. U is what I'm looking for. V is 28. Acceleration is not involved at this stage. T is equal to 20. So which of my SUVAT equations connects S, U, V, and T? Well, that one is S equals U plus V over 2 multiplied by T. So it's about substituting in now. We've got that 400 is equal to U plus 28 all over 2 multiplied by 20. So in other words, on that right hand side we've got 10 as a multiplier. 10U plus 280. 20 divided by 2 is 10. And then just rearrange that to get it. So we get what? 120 is equal to 10U, so U is equal to 12 meters per second. Don't do it too quick because we're showing U is equal to 12. Okay, yeah, part A done. Part B says, find the time taken for the van to travel from A to the midpoint of B. Okay, so in that case, I'm going to have a slightly different diagram here. I know that U is equal to 12 now. I know that the distance is going to be 200 meters, but that's all I've got. Okay, I don't have any other information yet. So if that's all I've got, I need 3 things in my SUVAT to be able to work it out. So what I'm going to do is go back to the original motion from A to B and work out the acceleration there, simply because we know that that will be a constant. So part B here. Before we do this, V equals U plus AT from the original part. So 28 is U. We know U now is 12 plus 20 A. So A there works out to be equal to 0.8 meters per second squared. That's still for that journey there. So I've worked out A there, but then that will remain constant throughout. So now, in fact, do you know what I should do, just so I don't confuse the examiner, is let's put that in first and say that's what I've done first of all. And now, for my second part of my journey, or the new journey to the halfway point, I can now say this is my halfway point, and I can say that I do know at this stage that A is equal to 0.8. So now when I do my SUVAT, I get more what I'm looking for, which is to have 3 of them and being able to work out what the 4th one is. So it only travels 200 this time. U was U, so it stays as 12. I'm not interested in V. A was equal to 0.8, and T is what I'm actually looking for. So SU, A, and T, that's one of our most often used SUVAT equations. S equals UT plus half AT squared, and we're just going to substitute everything in now. So 200 is equal to 12T plus 0.4T squared then, after 0.8. Tidy that all up. I'm going to make it, what shall I do? Let's make it 0.4T squared plus 12T minus 200 equals 0. And then I want to get rid of the 0.4 if I'm going to try and see if it factorizes or anything else like that. So if I multiply everything by 2.5, I'll get T squared. Now you don't have to do this. You could put this straight into the quadratic formula if you wanted. I just would have a quick look to see if that factorizes. No, it doesn't look like it factorizes anyway. Okay, so using the quadratic formula, t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So if I put that all in, I get 30 squared, minus 4 lots of minus 500, so plus 4 times 500 all over 2. And I'll just tell you then that that gives us t working out to be equal to minus 30 plus or minus 10 root 29 over 2, but I don't want the minus one, I only want the plus one, I don't want the minus one. That works out to be 5 root 29 minus 15, or if you're doing it as a decimal equivalent, 11.926, 11.93, something like that. Did it say anything? No, it didn't say anything about what it wanted it as, so either of those two things would be fine as an answer. Okay, on to part C. So for part C it says the van has a mass of 1,200 kilograms. During the motion, the van experiences a constant resistance of 260 newtons. Right, I'm going to be drawing a force diagram out for this. Find the magnitude of the driving force exerted on the engine as it travels from A to B. Okay, so not a complicated diagram, but I'd still do it every time I do a forces one. So what I've basically got is a situation where this thing has a driving force there. It has a resistance of 260 there. I don't think you need these, but I would still tell you that that's 1200 G, and there would be a reaction force here, but I'm only going to be resolving horizontally anyway, but just get used to doing the vertical forces, didn't need them. Resolving horizontally though, I'm only interested in this direction. We know that it's going with an acceleration in that direction there, so the F has to be bigger than the 260. So resolving horizontally, F equals MA, and that's going to be F minus the 260 then, that's equal to mass times acceleration, and we've got everything, 1200 times 0.8. So the actual driving force then is 260, excuse me, plus 1200 times 0.8. So the driving force actually works out to be 1,220 newtons. So another really straightforward question hopefully for you, and I hope that all makes sense.